Homework sheet 20, question 5. We've been given a coding formula, v equals t minus 5 over 10, but the table that we've been given in question 5 already uses these coded values v. We are not given access to the original bits of data. The first question asks us to find the value of a and b, which are coded midpoints. These are quite simply 5 over 10 divided by 2, which is 7.5. And b is 20 plus 30 divided by 2, which is 25. Most of the time a midpoint is very easy to spot, but if you can't spot it, simply just add the two bounds, upper and lower bound, and then divide by 2. In part B, we're asked to find an estimate of the mean, v, which we can call v bar. Our formula is that is going to be the sum of fm, frequency times midpoints, divided by the total frequency. We're going to need to work out our total frequency, so to do that I'm going to create a running total as I go through. 20, 44, 60, 74, 80. Sometimes the question does give you the information as to what n is, this one does not. So I'm going to divide the sum of fm by n. We are given the sum of fm, 825, just here below the table. N we've just worked out is 80. And that gives a final answer of 10.3125, which is 10.3 to 3 significant figures. Part C asks us to find an estimate of the standard deviation of v. Our formula for the variance is it is the sum of fm squared over n minus the sum of fm over n all squared. We were given the sum of fm squared as 12,012.5. Our value of n is 80. Now we could use our value of v bar in place of the bracket, but if we do that we want to make sure that we don't give a rounded version, so I'm going to play it safe and I'm going to put in the 825 over 80 all squared. Okay. The standard deviation itself is the square root of this. If you put that into a calculator, you get 6.6188, which is 6.62 to 3 significant figures. Part D requires us to use interpolation to find an estimate for the median. There are different ways of doing it, but the way that I prefer is to use a formula: median minus lower bound over upper bound minus lower bound is equal to middle value minus lower cumulative frequency over upper cumulative frequency minus lower cumulative frequency. And then if you're using this interpolation formula for the quartiles, replace the m's with q's, and for percentiles, replace the m's with p's. Taking a value from the table, our middle value is 80 divided by 2, which is 40. So we can fill that one in first. To find out which row our median value is in, we're looking at the cumulative frequencies for which row is the first one to take us past our middle value, which is the second one here, between 5 and 10. There are no gaps between the boundaries, so our lower bound for this one is 5, our upper bound is 10, our middle value as mentioned is 40, our lower cumulative frequency is the cumulative frequency of the row up to but not including the one that we're on, so it's this value of 20. Upper cumulative frequency is the cumulative frequency value of the row that we're on, so that's 44. Then I want to rearrange that formula and make m the subject. M is equal to 5 plus 5 times 20 over 24. And if I put that into a calculator, I get 9.16666, which is 9.17 to 3 significant figures. Part E requires us to actually work out what the mean and standard deviation were for the time spent using a mobile phone. So this is undoing the coding work that was done before. Our coding formula was v equals t minus 5 over 10, and so this needs to be rearranged. For the mean, t bar is equal to 10 v bar plus 5. I can then plug in my previous value from before, 10 times 10.3125 plus 5, and that gets me a new mean of 108.125, which is 108 to 3 significant figures. For our standard deviation is not affected by coding of addition and subtraction. It's only affected by any multiplication and division, which means I can ignore the plus 5 when I work out what my new standard deviation is. My sigma t value is just 10 times my sigma v value. This is 10 times the 6.6188 that I found earlier, which gives 66.188, or 66.2 to 3 significant figures. A very common wrong answer would have been to add 5 to that and get an answer of 71.